Good afternoon and welcome to OnCore Live 2022. I'm your host, Robin Bell, and we are really excited to be here today and glad to have you with us. This year on OnCore Live, we're introducing the Product and Technology Sessions, our new educational webisode track. We've got some great interviews that are coming up for you today that offer information and insights to help you benefit your customers and help their business. So what are these product and technology sessions all about? Well, the product and technology sessions bring research and product development teams together to share their knowledge about today's most meaningful advancements and innovation opportunities. On today's show, we've got two advancements that we want to share with you. The new Rogers-Griswold bonding study and insight into flame-retardant adhesive technology. We're going to have a Q&A at the end of the broadcast, but feel free to send those questions to us throughout the webcast. And please post those questions in the Q&A tab on your meeting toolbar and not in chat. The automotive industry, specifically the electric vehicle category, continues to search for viable adhesive and tape construction solutions that reduce the flammability of batteries and components, as well as meeting UL and other flame requirements. Avery Dennison Performance Tapes product manager, Scott Krusinski, is going to walk us through the Flame Tough adhesive technology, a portfolio of acrylic and silicone-based adhesives that have flame-retardant properties. So with that, I want to say welcome to OnCore Live, Scott. Very glad you're with us today.
Yeah, thanks, Robin. It's great to be here.
Yeah. So, Scott, tell us a little bit about yourself and your work with adhesives specific to automotive and electric vehicles.
Sure. So I got my first exposure to electric vehicles when I was at Ohio State, getting my bachelor's degree in mechanical engineering. I was part of the Ohio State Eco-Car team, and this team competed in a hybrid vehicle competition amongst other universities. So I was just a little undergrad. The real work was done by the grad students, but fortunately I was allowed to be part of the team, and they let me basically disassemble and reassemble the vehicle for the grad students to do the real work. But by doing that, it got me experience and helped me see what was going on behind the scenes, behind the scenes of a vehicle that a normal consumer doesn't really see. So following that, my first 5 years at Avery Dennison, I was in a role very much like Kyle's, where I was an application engineer, and I was solely focused on automotive applications. And during that time frame, I jumped all around the automotive supply chain. So I would be at OEMs and tiers and converters, and I got a ton of experience on almost every application in the vehicle that involves adhesives, by providing technical support to customers and our sales reps and business development managers. That was a really valuable experience to take into the role that I currently am in as product manager, where again, I'm focused on automotive, and a big part of what we're working on now is electric vehicles, and more specifically the battery pack applications. It's become a strategic focus area for Avery Dennison Performance Tapes.
There's a lot of interest in EVs right now. You've got a very impressive resume and one that positions you well to talk about the industry. So why don't we talk about some of the challenges that are facing the adoption of EVs?
Sure. So some of the main challenges facing electric vehicle adoption are safety, performance, battery life, and cost. The industry has done a great job of innovating to overcome these challenges, but we still have a ways to go, and electric vehicles, generally speaking, are still really early in the product life cycle. So in terms of safety, fire is a risk, and although this has always been a challenge for internal combustion engines that are gas-powered vehicles, battery packs present a whole different host of fire challenges. Because battery cells consist of flammable materials, and if one catches fire, a domino effect can actually occur. So one cell can catch on fire, then the next, and the next, and the next, and there's there can be 100 cells per vehicle here. So that presents some whole new challenges. And when that event occurs, that's called a thermal runaway event or thermal runaway propagation. So that's a safety and a fire risk. And then in terms of performance and battery life, the battery cells can be damaged or stifled by overheating, freezing temperatures, expansion, collisions, shorting, and more. And then in terms of cost, electric vehicles need to come down closer to price points that are more competitive with internal combustion engines. And helping on that front is scale and automation in production, along with material innovation that's helping drive down those costs.
So we're looking at a lot of challenges, aren't we?
Yeah. Yeah.
So let's talk about pressure-sensitive tapes. How are they addressing these challenges?
Yeah, so tapes are addressing these challenges in what I would say is creative ways, both as a primary solution and as an accessory solution for a wide range of applications. So you can see the picture shown there in that presentation slide. Those are many of the applications for tape, and there's actually more. It seems like every day there's a new application we need to keep up with here. So in terms of cost though, tape rolls or laminated die cut materials have an instant bond and can be automated for faster production. In terms of safety and performance, single-coated tapes with dielectric face stocks are being used for electrical insulation, and those are being wrapped around cells and cooling plates and structural pack components. And then double-sided tapes are being used to bond insulation materials within the pack together. So, for example, thermal runaway barriers that prevent thermal runaway from occurring after one cell is caught on fire. These thermal runaway barriers consist of mica, ceramic paper, foam, and/or aerogels that are often laminated together with double-coated tapes. And these tapes we can incorporate flame retardants with them to give them flame retardant properties that help mitigate the overall risk of fire.
Wow, that's pretty impressive. So why don't we talk about then your flame tough productions and flammability requirements for battery packs? It's a good segue.
Yep. Yeah, so as we began researching and assembling a portfolio for EV battery packs, we quickly realized the need for flame retardant adhesives and films. So there are various government and OEM requirements for preventing or mitigating thermal runaway events from occurring. And because electric vehicles are still emerging and rapidly changing, these requirements are often in flux and still in their early phases. All that being said, we often see the UL 9.4 as an adopted requirement for flame retardancy. So in the bottom picture there, you can see what looks like a Bunsen burner. And there's one picture with a cone right there, and then the other with what would be a block of material. This test is for the composite level or a component level of componentry within the pack. So take, for example, again, that thermal runaway barrier design. If there's a foam laminated to a mica material with tape combining it, that overall composite often needs to pass the UL 9.4 requirements. And those requirements dictate that the flame can only burn for a certain amount of time, and the flame can only travel up the material for a certain length. In addition to UL 9.4, FMVSS 302, which has been a legacy automotive flame retardant application or requirement, has adopted its way into EV batteries as well. So, all that being said, when we recognized this need, we launched a new brand of products and a new set of products called Flame Tough. And the Flame Tough line includes several different adhesives and films. So we have the Flame Tough acrylic, which is a flame retardant acrylic that has balanced properties. So it has been historically good for automotive, and then we incorporated flame retardants for it, and it would still work great for automotive applications, meaning it can resist the temperatures, it can bond to a wide variety of substrates and surface energies, but then it also has that flame retardant ability to it. And that's available in a transfer tape form. We also have it in a double-coated or a single-coated construction, where we often integrate it with the Flame Tough polyester that we have from Avery Dennison, which adds to its flame resistance. In addition to that, another adhesive is the Flame Tough silicone. This is a higher performing option that has better flame retardancy and better temperature resistance and other properties. It also can bond to extra low surface energy materials like a silicone foam as an example. So between these options that you see here, we kind of created a mix and match portfolio combining these different flame retardant components to address these battery pack needs for reducing flammability.
Yeah, you really are. You know, Scott, we're talking a lot about automotive. It really is an area of great interest right now, particularly with EVs. But where else would pressure sensitive tapes for construction be used?
Yeah, so there's a wide range of flame retardant requirements for a variety of industries and applications. The requirements are often specific to the industry and the application as well. So there's quite a few different ones out there. Avery Dennison Performance Tape's legacy in flame retardancy comes from aerospace, however. So we've had quite some experience over the years in aerospace, and aerospace probably has the highest need for flame retardancy. And there are two common flame tests for aerospace. One is the FAR radiant panel test. This is a very challenging test, probably the most challenging among the ones we commonly see. This is where the composite is in a chamber, and the chamber is elevated at an elevated temperature. And then there's a torch that is much more significant than a Bunsen burner that comes down and impinges the composite material. And under those conditions, it can only burn for a certain amount of time and a certain length. Another common aerospace flame test requirement is the FAR vertical burn test, which is actually quite similar to the UL94 test that you just saw in the previous slide there.
Mm-hmm. Yeah.
In addition to aerospace, though, you know, we see some flame requirements, especially the UL94 in consumer appliances. And then we also see some UL requirements in building construction applications, as you see in the bottom picture there. A lot of HVAC and mechanical insulation type applications do require a level of flame retardancy.
Yeah, a lot of applications here. I think it's pretty common knowledge that Avery Dennison devotes a lot of research, product development, and resources into new innovative solutions. So how can our viewers take advantage of Avery Dennison lab capabilities and support?
Yeah. So we offer a ton of support to our customers. You know, Kyle Witham was just on this call. He's an application engineer. We actually have a whole team of application engineers that specialize in promoting or providing technical support for our products, and they really know applications and how materials interact together. And then behind them, we have a whole lab of capabilities that we use all the time, and we're happy to test for our customers. This lab consists of the typical tape industry testing standards like peel, tack, shear, and release testing. We have all these chambers for elevated temperature testing, humidity testing, and then we've been incorporating some new capabilities as we've been entering the EV battery space because there are some requirements that are a little more unique for that. So we have a burn chamber, which is great for doing all the burn tests that I was just talking about. And then we also have a dielectric strength tester to measure the dielectric properties of material stack-ups. And something we're always eager to do for our customers is, just like we did with the bonding study here, is that if our customer wants to see how a particular material interacts with a variety of our tapes, we're happy to get that in, and we can test it to the full gamut of testing that we have available to us. In addition to that, the lab is ISO 17025 certified, which means we can test to automotive or other OEM specifications, and then we can issue a certification of that testing data, and then our customers and converters can take that to their customer and present a qualified solution.
There is a great deal of support and a great deal of materials that are available to your customers to better their business. I want to thank you for spending time with us today, Scott. This was really interesting. I know I've looked at chat a couple times here. We've got a lot of questions coming in. Thanks for your insight, and thanks for what you shared with us today.
Thanks, Robin. Yep, thank you.
We want to thank you for all of you for joining us today. And be sure again to, just a quick note, to check your email Q2 for our next OnCore Live. Until then, take care.